Hi class, and welcome to another video lesson. We're still on section 7.9. We just got done doing a lesson on where we interpreted graphs just by looking at them and seeing what similarities and differences they have. Now we're going to actually be graphing them. So make sure you have your graphing calculators out because we're going to be using them in this lesson. So for number 5, these square root functions, they always have this type of a shape to them. So a very important point to figure out is this starting point. Where is that? And it's very simple to find. From our origin, you go up and down the number that is outside our radical. So 0 is outside our radical. So we're going to go up and down from the origin 0. So hopefully that's easy enough. All you got to do is look at that number to see how far up and down you go. Now your x coordinate is always going to start when underneath your radical is 0. So when is 2x minus 6 equal to 0? Well, we simply solve for x. 2x now equals a positive 6 when we add 6 to both sides, and then dividing by 2, x equals 3. So your graph is going to start at the point 3 and 0. Once again, we got 3 by saying when this part equals 0, and then your y-coordinate is the number outside the radical. So at 3, 0 is where your graph starts. It's going to start right there. So that's the first place you always start, class, is where does your square root function start? It's kind of like that vertex. When we talk about sideways parabolas, we talk about this being the vertex. And remember, square root functions are just half of a parabola. So it's right there. So your vertex, so to speak, is going to be when your radical is 0, set that equal to 0 for your x-coordinate. Your y-coordinate is the number that is outside of that. Now, to find the other points, all you're going to do is use your graphing calculators. So please take out your graphing calculator and put in y equals. For now, we're going to pretend this is an equal sign. I know it's less than, but we're going to pretend it's an equal sign right now. So y equals the square root of 2x minus 6. Y equals square root of 2x minus 6. Make sure that's all underneath the radical. Our calculators might be a little bit different. Make sure that if yours looks like mine, you close the parentheses after that to tell your calculator that all of that is underneath the radical. If you have one where this is extended, make sure all of that is underneath that radical sign. And then you're going to press graph. Here's what our function looks like. As you can see, it starts at 3, 0, and that's where we wanted it to. That's what we found out on our own. We're going to pick 2 more points. So pick 2 more points somewhere along in here somewhere. And the way we're going to do that is we're going to look at the table. So you're going to go to second graph, which is the table button. As you can see, we're starting at 3, 0. Everything to the left of 3, we have errors, because then it'd be taking the square root of a negative number. Now you're going to want to plot convenient points for your other 2 points. So right here, here's another convenient point. So you're going to want to plot the point 5, 2. So let's go to our graph at right 5, up 2. There's another point. I want to see this on your test class to make sure that that point is very evident to me. Now let's pick one more convenient point. So 5, 6, it's at 2.4. That's not a very good one. 7, 8, 9, 10. Okay, I guess there isn't any more convenient points. When there isn't another convenient point, just pick one more and try to approximate. This one is at 9 and 3.46. So let's put 9 and 3.46 on our graph. We're going to have to approximate. It's not going to be perfect, but that's okay. So at 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and at 1, 2, 3 and a half, 3.46 is about 3 and a half. So there's our graph. Now instinctively, we connect the lines and we're good. However, remember this is an inequality, so it's not an equal sign. So we're not going to have a solid line connecting those dots. What we're going to have is we're going to have a dotted line, because if it's less than, we're going to use a dotted line. So that's what our graph looks like. Now, when we have these inequalities, we also do shading. When it's greater than or equal to or greater than, you shade everything above the line. When it's less than or equal to, you shade everything below the line. Same thing is true with these square root functions. If it's less than, you shade everything below the graph. So you're going to have this cutoff here at 3, and you're going to shade everything below. So your shading is down here. Now your shading is going to follow this dotted line as it goes up and to the right. And it's going to go down for negative infinity. Okay? So that's how our graph looks. This is what I expect to see on a test. Okay? So I just want to make sure that we're very clear in what I expect from you. I expect you to have the vertex correct. Okay? I want to see this work where you set it equal to 0 and then you solve for x. Okay? I want to see 2 other points on your grid. So this point and this point. I want to see the dotted line that connects these dots, and then I want to see the shading. So all of those are what I expect from you on your test questions. Now our domain and our range, both in interval and set notation. Our domain, as we go from left to right. So as I go from left to right, my x values start right there at 3. So I have a domain of 3, and because it can equal 3, I put a bracket there. Now how far to the right do I go? This red dotted line continues to go forever to the right. So I go from 3 to positive infinity. Infinity is always has a parenthesis behind it. So my set notation would be x such that x is everything that is greater than or equal to a positive 3. It's everything to the right of 3, so it's greater than or equal to 3. Now my range class, be very, very careful when you do your range here. So my range, as I go from the bottom up, how low does my shading go? My shading goes forever downward, doesn't it? So it starts at negative infinity. A lot of people say that our graph starts here, which is where the dotted line starts. However, the shading is what we pay attention to. So the shading goes infinitely downward. So it starts at negative infinity. Now, how far up does my shading go? So as I continue to go up and up, my shading continues to follow my dotted line right here. So my dotted line is going to continue going up and up and up and up forever and ever and ever. So my blue shading is going to continue going up forever and ever and ever. And I realize I just made a mess there, so I'm going to erase that. But I want you to get the message, I guess, that my shading is never going to stop. It's going to continue following this red dotted line. So my shading is going to go from negative infinity all the way to positive infinity. So it's every real number, all real numbers. And that's what you're going to put for your set notation. Y such that y belongs all real numbers. That one is very tricky. If you have a hard time understanding that, be sure to ask me questions on that tomorrow, because it is a big concept. All right, let's try number 6 and number 7. If you're kind of confused right now, hopefully after we do 6 and 7, it will be more clear as we move forward. So this one, y greater than 3x, the square root of 3x plus 5 plus 0. So I'm going to find my vertex first, where my square root function starts. The x coordinate is when this equals 0. So when does 3x plus 5 equal 0? Well, you're going to subtract 5. So 3x equals a negative 5. And then you're going to divide by 3. So x equals a negative 5/3. Your x coordinate is going to be a negative 5/3. Your y coordinate is that number outside the radical. So it's this number right here. Once again, we're starting at 0. So go left, negative 5/3, which is a negative 1 2/3, right approximately there, and 0. So that's where your function starts. To find the other ones, we're going to put it into our graphing calculator. Y equals the square root of 3x plus 5. So go back to here, clear whatever you had in your y equals. And now you're going to put in this one. square root 3x plus 5. Hopefully you got something that looks like that. Now once again, I would pay attention. Where does it look? This is a good check on whether we did our vertex right. Doesn't it look like it's right in between 1 and 2, maybe closer to 2? So hopefully a negative 5/3, our vertex makes sense for it to be right there. So that's where it starts. Now we're going to find several other convenient points that we can put on our graph. If there aren't any convenient points, then we're just going to have to approximate. So we're going to go to second graph, which is our table. So if it starts at a negative 5/3, as you can see, a negative 5/3 is right in between a negative 1 and a negative 2. And so that's where our error is. So what are some other convenient points that we can plot? I'm not seeing very many convenient points, if any at all. There aren't any, so we're just going to have to pick a few. So you guys can pick any one of these, I guess any two of these, because I want you to put 2 on there. Let's put in 1 and 2.8. So this point right here, let's put on our graph. 1 and 2.8. So you're going to go right 1 and up 2.8, so about 2 3/4, somewhere right in there. Our next one that we're going to plot, let's put in, how about 5 and this 4.7. So go right 5 and up about 4.5. 1, 2, 3, 4, 5, and up 1, 2, 3, 4.5. And this would be good enough for me on your test, class. Now you're going to connect these dots. Be careful what line you use to connect those dots. It's a greater than symbol. It's not greater than or equal to. So once again, you're going to use a dotted line to connect these. And that's what that graph looks like. Make sure you don't forget the shading. This is a greater than sign. So greater than means that you shade everything above your graph. So this line is going to be your boundary, and you're going to shade everything above. So there's where your shading takes place. Now we're going to talk about our domain and our range. Our domain, as you move from left to right, where does your domain start? It starts right there. And what point is that again? Where does your graph start? At a negative 5/3 is your x-coordinate. Your y-coordinate is 0. So for your domain starts at a negative 5/3. That's where your shading starts. Your shading starts right there. And then it goes everything to the right. And how far to the right does your shading go? Well, it goes as far right as this dotted line goes. And this dotted line goes infinitely to the right. So it goes from negative 5/3 all the way to positive infinity. So then we would say x such that x is greater than or equal to a negative 5/3. So now for our range. Where does your shading start at your range? Your shading starts, as you can see, this red, I'm now going to have it in blue. It shades, 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 and it goes all the way down to that point of 0. So it starts at your y-coordinate of 0. And then how high does your shading go? It continues to go up and up and up. It follows this dotted line. Infinitely it goes up. So this goes all the way to positive infinity. So your range, it starts at 0, and it goes all the way to positive infinity. So your range is y such that y is greater than or equal to 0. 0 to positive infinity for your interval notation, y such that y is greater than or equal to 0 for your set notation. All right, you guys try number 7 on your own. Try to follow your notes on number 5 and number 6. Let's see how you come up with for number 7. All right, after you've tried number 7, after you've paused the video and tried it on your own, here's what you should have come up with. Your vertex, where your graph starts, is when this equals 0. So when does x plus 3 equal 0? When x equals a negative 3. So at a -3, and then your y coordinate is this -2. So at -3, -2, there is your first point. Now you had this negative sign in there, class, so that's going to play a role into how your graph looks. Let's put this into our graphing calculators. So we should have a negative square root of x plus 3. And now we're going to get out of our radical. So some of you might have to press the right button. Others of you just have to close that parenthesis and then -2. So we graph this. As you can see, it does start at left 3, down 2, so we did our vertex correctly. And then it's going to go down and to the right. And that's because of our negative sign right here. So it's going to go down and to the right. What other points can we put on our graph? If you did this on your own, hopefully you got a -2, -3. That should have been in your table. A +1, -4. That's all I would need to see, but I put in one more so we can get a good picture of what this graph looks like. We're also at right 6, down 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Once again, you get all 3 of those red points just by putting them into your graphing calculator. Now this is a less than or equal to, so that means it's going to be a solid line that connects these dots. And because it's less than, your shading is going to be everything below. So your boundary is right here, and you're going to shade everything below the line. So it's going to be everything down here. So for your interval notation, starting from left to right, it starts left at a -3. Right here is a -3, and then it goes all the way to positive infinity. So from a -3 to positive infinity. So your range is x such that x is greater than or equal to a -3. Your y, your shading starts at -infinity. This goes infinitely down. So it goes from a -infinity, and then where does it start, or stop rather? It stops at a -2 right here. Your y value of a -2. So it would be y such that y is less than or equal to a -2. So that's what we have when we graph those inequalities. There's going to be a worksheet on that tomorrow where you have a couple practice on graphing those. Be sure to let me know if you have any questions when you come to class tomorrow.